All right, welcome. Today I will be streaming some x64 live coding, and I finally gotten a handle on the API in Clang. I think mostly I've done now x66, x64, arc64, and the Win64 ABIs. And the x64 is by far the most complicated one, and maybe unnecessarily so. I think a lot of it has to do with how Clang works and how it handles a lot of stuff. And so because of that, I will be starting with the implementation, which is following Clang a lot, and start reworking that. And actually I've done some work already, and my code was not completely done, but I have like some tasks that choose the C ABI will look like structs, but they are not structs in C3. And those types are they are the array union, and here's the array type. Sorry, here is the array type. So we have the array type, which will contain. If you handle that, usually you will not pass it around, but if you do, it's actually a type that is a struct, and that struct type is not larger than a pointer size, but it has to be handled as if it was a struct. Otherwise, the C ABI will be confused by this. So I can't pass it as a simply a pointer, even though it could be. It will have to be follow the same type, the same rules as the structs. So right now I'm actually just working on the regcall structs, and it's doing some stuff here. And we have these different types that are possible. And actually I don't think this is quite correct, because I don't think that anything here should expect a union. But that is the way it's actually coded in Clang, and I don't think it's correct. I think the union should basically be reduced to whatever type is the largest one with the largest the biggest alignment. But I will need to, for now, just follow along with Clang. So here I've changed this. I've added a helper class called registers. Sorry, the class struct. So I will use that instead of having passing them like this. They had like pass each of those by pointer instead of having a struct containing both. I don't know why. It just seem more complicated. Needed registers. Maybe it's like, okay, if you want to do something and it's you know, it's we need to make a class, and didn't want to make a class, so they sent implicit arguments. But I think in C it makes more sense to do it this way, and actually more elegant, I guess. So we now want to pass in the number of registers, and this is a reg call. Yes, it is. It will always be a reg call if we reach this point here. And so we want to classify this argument type, but actually I think this might be wrong, because this is, let's see here. So this one is the one that takes just the, like, does everything including let me see here. So we go down to this one, and it's going to classify, like either it's going to be the classify argument type, and that one is going to do something down here somewhere. Because I'm refactoring, it's not really working, jumping between these. So okay, so this is the classify argument type, and as you see here, it's like assuming that it's a reg call, it's like handling the reg call as well, and that's why they didn't want to have this part inside of this call, which makes sense. So we're just going to do that, follow it more cleanly, and that means that if it's a reg call, then we'll use this one, and if it's a see here, so if it's otherwise, we want to do this way. So in case it's a reg call and the type is struct like, or the type is a union, I don't think this is correct, by the way. Then we're going to use this, and we're going to have the needed registers, and we're going to pass them in, and we're going to get a possible type, and we'll do the same thing, but without, like if it's not a reg call, we will do this, and I maybe we'll clean that up. And okay, so if these registers, try to use these registers, the needed registers, the available here. So like we have these available, and these are the used ones, and we need to pass in the references to those. If it's okay, if we can't do that, then we want to create an indirect result instead. So in that case, the info will become this one. Just make those, and we will pass in whatever is needed, and we only need the type, which we already have, and the number of free registers, which is the registers. Let me just going to check the call here on in Clang. So we're just going to pass in the free registers from here. So we have the available registers. Oh, it is this one. Okay, and what does it say? In case we do that, then we just get the indirect result. And isn't that going to use a register? No, it doesn't care about that. Like here, I would expect this to actually use a register. But it doesn't. Okay. So then we have decided what the info should be, and then we just assign that here. And then we continue to the next one. So basically for every parameter, let's go through these and do stuff. But we have one thing here, and we should move all this into a function for reasons that will become obvious later on. So, but we'll do that later on. Okay, so we're going here and we are doing this. Okay, we're going back to the, let's see here, we have the classify argument type and classify this. We are going to do this. Okay, so here we are. No, we need to sorry. So we need to this one. So it's going to look different now. We don't need the reg call anymore. And let's see where that one is. So I'm just going to search for the name here. So we have the next one there. So now we don't need the reg call. And here is the main ID here. So we have the needed registers, and then we do the needed registers. We go to count up, and we count up, and this here. So this should never happen now. Didn't I fix this? This weird. Okay, so I've now like decided that this will never happen. Class, no class. Because we have decided, so empty first 8 bytes not allowed. So this will only happen if we have like a struct that is completely empty but still has padding. And what I've determined is that this will only be true for C++. Right, so let's see here. We are in classify argument type. I need to check this code again. So classify argument type. I need to keep checking that I'm not like doing any mistakes here when I do the call, the changes in the code here. So let's see here. We are increasing the number of registers. This is like a bit confusing because we need to increase the number of needed registers here, and it should, do that in the same place, I think, for both of them. So right, and see here. So we do a merge here. Possible. We have like if you have a high part, then we return an argument pair. Otherwise, we will have it plain and just have the direct. Hang on, this is not correct, perhaps. So let's see here. So yeah, okay, sorry. So if we have a plain type at this point, and the point is the same as we originally had, then we're not going to do any changes here. So this is just simplifying this the code a bit. Otherwise, we have a queers thing unnecessarily. So this is more an optimization that I added, because it turns out that Clang will do that automatically, but I won't do that automatically. And let's see here, if are these the same? Yeah. Okay, so let's look at the reg call for structs. And let's see what it does. So if it is a struct inside, then we will do a reg struct type check. And let's see here. And otherwise, we will just try to do a classification on the type, and we want to do something like lowering that type first. So we have the member type. We basically say that the number of free registers are infinite, and we take all the registers, all the best registers, and we have named argument. This is something we don't use at this point. And then we take those and we want to add those to whatever we had as the number of needed registers. So we want to add, like we had the needed registers there. The SSE registers would add the temp registers. And we're just going to add those up. So it's obvious at this point that this is incorrect for unions. This is just give crappy results for unions. let's see here what it does, the original code here. So if it is a record type, but it's not a, so if it's x86, not 64, I had a function here, and perhaps it's further down, that I use to determine if it's a struct for this. So here it is. So I'm going to add that as a function up here. So basically, if it is a struct in this sense, struct, then we will take this member type and try to classify that one. And hang on, I think this is, so let's see here. If it is weird. So we have a local. All right. So okay, it's actually zeroing out those numbers. This is correct apparently. So if the member is a struct, and that is like it's a record type, which is like it's not a union, then we're going to call this. Otherwise, we're just going to classify that one and just add it, which is odd, honestly. It will basically start, ignoring registers at this point. I don't think this is correct. I don't know if this is even used, And okay, so then we sort of oh no, hang on. It's just going to classify the type. So hang on, I'm just going to make sure that, okay, so no questions so far. Okay, so this is a bit weird. So in case it is a union type, then we try to classify it like this. So we try to do a classification like this. Sorry, hang on, I'm just going to hold back. All right. Okay, so apparently what we do is it just wants to say if ABI indirect in this case. So if we would pass by memory at this point, then what do we do? According to the ABI, then we just want to return an indirect value result. So here we will just return a new indirect result using the x64 indirect result and using the type, which is the type that we got from the beginning. So like this, if it's an indirect, then we just bail. And then we also set the needed ones here. So the we want these to be set to, basically we want to reset those like this. Okay, but otherwise we apparently continue. But if it's not, then we will, let me see here. So it's not zeroing things out. Okay, that makes sense. Good. So in this case, on the other hand, it will put those in temporary, do a classification, and let's see if it's indirect. Okay, so if this, in this case, ABI is indirect, this thing, if it's indirect, then we again set the needed registers to empty, and we return using the x64 indirect result type here. Okay, and now we are going to add those here, right? So that is the flow, I think. And then we basically go to the next one. So you might notice that this is not particularly, these are the same, so we could basically do this, then always do this, and then instead of having the needed registers, we do the temp ones, right? So now it's doing pretty much the same thing. We see the same thing at the end. Now we can pull this out like this. Okay, boom, we have that. We could do one more, just ternary, but that would not help reading it. So I think this is better. Okay, so it will go through each member, try to classify it. If it's indirect in some way, then it will, we just zero out the needed registers and return an indirect result. That makes sense, okay? And otherwise we just add the needed registers. And I don't think the needed registers here are like so that makes sense. I think that's good. Okay, and now we can figure out what needs to be done here in this case. If we have an error union, then we have two types, and those are integer types. So they should be like, it should be like, for example, this should be like for unsigned I equals 0, I is less than 2. And then we have the type, which is usize, right? Or it could be type void, actually, void pointer. So we have basically same element type of these two. And we're going to do, here we know that this is not a structure. We know that all that we need is to do is this part, right? So we can basically take this in here. We know what the element type is. We don't need that. We just need to do the part then. Know that we'll have, use the infinite number of registers, and we'll know that we'll pass this in memory. So I can just do like this. And I know that the element type is whatever it is. And we know that it won't be indirect. So we can assert for that. So assert member info not ABI type is indirect. So because we know that, and that means that we only need to do this, but then we can move this out, right? So we just need to, we can see that this is true. We just need to use these twice, right? And then we return the member info, which is, no, it's just going to be like a direct run, right? So it's always going to be do a direct return. And this is also going to be true for, that was something weird, okay. So it's also going to be true with the string, which also contains 2 pointers, and it's also going to be true for the subarray. So all those are returning the same thing, which is the type-sized thing. But get in here, it's going to find everything right, and it's going to say like, okay, we need, I guess we're going to need 2 integers, and actually we can figure out that we are going to need 2 registers already. So we don't even need to do this. So we can remove that one. Basically say, let's use 2 int registers for this, right? Because what we have here is this is going to take 8 bytes and 8 bytes. In the case of, we are assuming we're not using 32-bit pointers, which is something I'm not supporting. So in this case, just use 2 registers in the array call and pass them directly. And what will happen here? So if it's not a register, then we will pass that by reference. So that makes sense. Okay, so then we're done with that part, and we're just going to, have this here, I think. Let's see, it's the native registers, and we're going to put those there, right? And we try to do that, and if it's not, then we'll put it in there. Okay, so now we do this classification, because here we didn't really say what the handle the integers. So in case we have a type here, like we might get something else. Let's see here. So we get int type at offset, right? So if it's a struct, we are fine. We are getting a member at offset, and now the offset is, we have to make sure that the offset that the offset is either 0 or the offset is, I think the offset should be 0.8. So, but I'm not sure. So we get an int type at the offset. Then we have the rest of the ones, right? So we are not handling at this point. We are not handling type, the array type. So in that case, we get, regardless of what offset, we will get an int type at that offset, which is, and the same with the type subarray, and the same with the type, which one was it? So string. And for all of those, we get an int type at the offset, and let's see what the int type becomes. So if it's a pointer, then we get the one. So we're just going to return an ABI type new plain type void pointer, right? So it's just going to return that regardless of the offset. Only contains 2 void pointers, because that is how it looks like to the ABI. Right, and then we have another one, which is case type error type here, because that one behaves, no, okay, so this is a union, sorry. So we get a member here. Let's see that it can actually match that. So we get members, and that's from struct. And struct is something unions, type, and struct. So these are the ones that have struct. And this might be empty actually for the type at this point, which is sort of maybe bad. But then it will be empty and will be passed maybe as an empty thing, and that's why we need to actually add a padding member perhaps to the array type, but that's for later. So this will break later on, and we're aware of that. And maybe it's bad now to have the default, because we don't know that we're handling all the types that we want to handle. So we have a bunch of types. So this is unreachable. You should never have a poisoned value. The type void should never be there. And also this one should be lowered way back. And these are fine. We handle those. And let's see here. So this one should not happen either. The type ID should be lowered. Enums should be lowered. Funcs should never be raw. Unions. What about unions? They are handled as their size. The type def should never be there. Type info, member, those should never be there. So we will handle vector, complex, and so on in the rest here. And I'm just going to check that this is get the int type at offset. So there will not be an int type at the offset, I think, for the vector. So, but just let me have a look at that. Get integer type at offset. So pointers will do. Arrays it will do. Otherwise, we'll just classify it as an integer. So that's why what we'll do here. That's fine. And actually, it probably would work for these as well, but it's more clean to do it as it is. I think the pointer is handled right, so pointer is here. So okay, so that's fine. Good. Now we've done some cleanup. Things might still break, so I'm just going to see if everything works at this point. So it just compiles. It compiles still, and that means that there is no compiled error. And now since it's sort of working here, we might continue looking at this code here. So we are handling this correctly, and I said this is something we want to refactor, and I'll explain in a little while. So in this case, let's move this out. So ABI func classify, sorry, x64 classify parameter, maybe the type. That's the one we want. Type. We start with that. See what we want to pass in. So we need the return. It's an ABI info. And we want to do the lowering perhaps ourselves. So let's do that. So we take the type and lower it. And we need if it's an array call or not. and we need the available registers. We want to pass in those. So we have registers. So now it's fairly happy about that. And since we now can do this instead. So like this. And like this. Okay, and then we return the info. All right, now we have a function here called classify parameter. So we're going to call that one instead. So return, params I. So var ABI info equals x64 classify parameter type. Right, and this we needed the needed registers or available registers, sorry, and if it's a reg call. Now I can remove that call, no, that data. And now I also want a classify return. This is fine because this is handling the reg call splitting. Okay, so why do we need this? It's because if it's a the signature is failable, then we want this to be, we want the failable, so the failable, where is it? So now I am completely at a loss. So we have the return, we need this one as well. So struct ABI failable ABI info. There might be a failable, and then we need a failable ABI info. In this case, the return type is we're going to take this, and the type is always going to be a type, not error, it's an error union. Where is that one? All right, I don't think we made that one, so it's special. We need to introduce that one. So we introduce a type error union. And I think that's the error actually. Yeah, oh, sorry. So the error is the error union. Okay, let's see here. So we're just going to give it the type error. Otherwise, we have this ABI info there. And so if it is indirect, so maybe we want to have so this or this. Right. maybe we should do this differently. So all right. Okay. So in this case, if we have a, so it's going to be like this. So if this is indirect, then we are going to remove the one register, right? And then we're going to classify the return as a normal parameter. The signature is going to be one of the parameters. And otherwise, we do like this. And take the return ABI info, and then we do the normal thing. So we don't need to do this part. And then we do the parameters. And now we're fine. Now we're doing creating the ABI compatible with failables. And we can remove this. So this is fairly cleaned up now, this thing here. And this is, I think, fairly cleaned up now. I can probably just return here. Whatever, so it's maybe okay. Look here, this looks weird in the name thing. So there's some reason why that shouldn't be there. Okay, so we have this. Let's look at the, this is a classified argument type. This is not very complicated. Actually, at this point, we have the high and low class. We're classifying those. We don't need really to do it like this. We could just put them inside of, since we have the pair, we could put those in, classify and say, okay, hey, classify the pair, right? But I don't know. It's not very important. Okay, and then we go up to the classify return. It's going to look a little different. I don't know how different. Maybe we could just put them together mostly. But I also going to leave that for now. And here's something like the pair return. And that can't happen either. So we have a bunch of things in Clang that can happen for us classes. That doesn't make sense for us. Okay, so the byte vector type. Let's see here. The byte vector is, let's see here. Okay, we have something called a byte vector type. I'm just going to see if I can make that simpler. So, trying to find a single element struct of that. And it's, let's see where we come from, where we use that. So, that will only happen if it's an SSE. We can then assume that we'll have stuff here that is, we're looking for the single type, right? If it's a single element, then we use that instead. We do the type lowering on that one. We look if it's a vector, and we can pass these vectors in memory. And it's a type which is in this thing here. We don't pass VXI 128 vectors in their native type. The backend can't legalize them. Okay. Right. So if it's that type, then we are converting that, and then we are going to put those as fixed vector elements. I don't know why I decided that I need to check the signedness. That is not necessary at all, because we will basically do a coerce there. So we don't need that. So we just need a type long. Right, and then we have a vector. So we get a vector, fixed vector type with the underlying type being an int64. Right, so this should be so it's going to split that one up into two pieces of size of. So we did already know how, we have the size somewhere, right? Okay, wait. So this here, so we didn't get the size, the type size of the type. Don't we know what the type is? Oh, yes, we know that the element type. So we don't know the type of the size, so we need to divide there. That also means that we don't need to do this. We don't need to, get this element. We don't need that. Instead, we should basically just type u long. Sorry, yeah, u long. So we just need to use 64. Okay. Otherwise, we're fine, and we're just going to return the type. And then we continue. This is the case if we have a vector. And then we have the case where we have an f128, and then we going to go by size, and we get, if we have, there is some assert saying that we need 16, 32, or 64 bytes wide. And then we try to get a fixed vector with a double, yeah, and then we have the size of 8 divided by 8. So we get a vector with a double. Right, so that was as simple, I think, as it can get. And this is the case, so it's just trying to have this special case here. So it's trying to do everything just in case we have this, and we want to pass that in mem. No, sorry. Oh, so we're passing all vectors in memory. No, we paste them as plain. If we have a vector, just go for it. And otherwise, if it's anything and it's like something big, which doesn't really make sense because we pass all the vectors here, but okay, whatever. So in that case, we're just going to make a vector type. Oh, maybe it's a struct or something. Can it be that? I'm not sure actually when this happens. So we have a single type, and the type is maybe it's a complex type. So that could happen. Okay, then we are done with Byte Vector. We have done this. We have the SSE type, and that was super simple. So there we have it, and contains a floated offset, and we will maybe have that. So we have a struct. Hang on, so this one is incorrect as well. So we are going to look at that one. So for the SSE, contains float at offset. So, okay. If it's a type and it's F32, oh, hang on. So our structs, yeah, it might be a structure. So if the type is struct-like. Now, actually, this is just for two of those. So it's if the type is a type struct or an error type, or it's a type is an error type. So these are the only types that can, so these are the only types that can actually contain something deeper in, that is that it might be a float, because the error might be like 2 floats or whatever, or 1 float. So this is fine. And then it could possibly be an array as well. Otherwise, it's not anything and doesn't contain a float. So let me go up here, and then we're going to look at the contains no user data. Contains no user data. Contain no user data. Contain no user. So bits contain no user data. That means like it should be in padding or something else. So first we go look at the array, and then let's see if it's like in the offset somehow. I guess I have to trust this calculation. It's like the same as Clang does. And then we have the union or struct, but this is not correct. So we have, maybe it's a type is struct-like, right? Or it's a x64 type is structure. Okay, first of all, if the type, okay, so we have these, like let's handle these. Type or no, we just have these cases. The ones where we can have padding is like the type kind could be type struct, or it could be a type as a type reunion, or the type could be a type union. No, it just type. So, and then these rules hold for all of those. Okay. We will continue up here. Classify things. Okay, so if it's an error type, we should not classify that as an integer. Sorry. It has to be classified as a struct union. And then, let's see, it goes through the members. So that's correct. If it is a subarray or an error union, then we do this. It's correct. Do we have anything else that is similar? No, those are fine. Get member at offset, we already tried that. Classify complex, and that should be fine, totally changed, unchanged. Classify the vectors. We are going to leave that for now, I think. Right, so this could take even more fixes, but it sort of should work, except for this one. So there is a difference between the named and unnamed parameters. And I am unsure how that works. I will research that later. Let's go to the next thing that doesn't work quite, which is this one. Classify stuff for x86. So we were talking about this one. It has to be something similar. So if the signature has a failable, then we want to define this one. And then we want to do the other one as a parameter. So it's pretty simple. Otherwise, just classify the return. And we note here that we're not doing the vector call thing at all. But this is now passing the failable thing. So now we should be okay with failables. And we're doing the next thing is going to go to the, so we have the arc. Let's see, this one. And here it's pretty simple. We do the return type. Again, we're going to do the same thing. So if signature failable, then we are going to do one thing, and that way we'll do the other. So we are going to do the failable, and I remember I was doing the wrong thing here. Of course this can't be this one, so it's a type error. There. Now we go back to this one. Okay. So at this point we want to do this, and we're going to do a normal classification of an argument type, because now it is an argument. And we are going to return whatever that is as a pointer, right? So we want to have that one as a pointer. I didn't do that. Type get pointer. And want to do a type lowering for that one as well. But only if that's a non-void. Damn it. So if signature return type kind is not type void, then we're going to do this. Oh no, it's going to skip it anyway. So it's going to put a ABI skip for us, actually. But not if we do the void. So let's perhaps do this after all. So we need this extra thing. So if it's not a void, then we do that. And we need to do the same thing here for x64. So here, somewhere. Okay, if it's failable, here, if that's not a type void, then we do this, right? And we do the pointer to that. So we have a type get pointer. We do a lowering on that one. So what do we, yeah. have something that would type info, something I have to look at later on. Okay, so that's load type, and we do the same thing with the x86. Again, we only do this if the signature R type kind is not void. In that case, we will want to add this one. Do a lowering on that one, and then do a get pointer. Okay. Let's see here. That was there. This one has that as well. And now we go to the Win64, which is the last one. So again, something similar. Here we have classify. Oh wait, yeah. So that's the classify here. That will be the else. So we want to do this one for type error, and then we don't need that. And in that case, we want to do this almost, but with a pointer. So we want to have this false because it's a parameter, and we will do the type lowering on that one before we get the pointer to it. Type that is not strictly needed, because the pointer will never. Pointer is a pointer and will be handled as an int usually, but it's a bit cleaner to do that. Okay, so this is Win64, yeah. Now we should work. Actually, we should be able to do some. We could try to actually have a failable, and that will probably break. But let's do that. Func int foo. So it's an external. So let's see what happens now. Okay, so it's going to, let's see what it looks like. So what I expect is now not this. This is incorrect because it should be a failable, and maybe I didn't handle that. So if it's a failable, let's see what happens here. So we don't have a foo here, or do we? So let's see what the type is. So this was not it. Take the next one, and taking the next one. And that is the int one. So let's see what happens now. Okay, so is it failable? Yes, it is failable. Let's see what happens. So we're going to failable info. API is indirect. We're going to make that one return API info. But apparently my function thing is not doing it correctly. So when it's going to make that one, let's see here, gen emit type is for the type, sorry. So the type, function type. In this case, it's going to say, so if the return type here, it's apparently not caring about that. Okay. Let's do it like this. F, so type, real return type equals signature is failable. In that case, the real return type is a type error. Otherwise, the type is signature or type. Canonical. All right. So, and the same thing with ABI. So if it's ret arg info, this one is if it's failable, then it's going to use this one, right? And then this means that the return type here will be so like this. And let's see if we have the type here. Okay, so that would be the type. And then if we have like if let's say vec size of these parameters unsigned params equals, did I use params already? Yeah, param size. If signature failable, then we're going to add the param size plus. So if it is signature is failable, this can be improved later on. If it's failable, then the param is if it's going to be like param is I is bigger than 0, then it's going to be like signature params I minus 1. Otherwise, it's going to be no, we don't want a decal, right? So we just need a type. Okay, so we have the type param type. So if I is bigger, then we're going to have like the param type is going to be a signature params I minus 1 type, and the ABI info org. Now this is just going to be super icky. I hope you all see that. So let's take this one. So assume we have a type param type, and we have an IBI info. And we have a params. Okay, so then we take this one doesn't need to exist, and this one does not need to exist, and we just take let's call it arginfo because that's what we did. Now we are taking the param type instead, and we're just going to do the param type, and then we're going to do the param type canonical. Yeah, I guess why not? And we are going to take, we have the context. Okay, so we need the context. Right, so now we have the context. This is something we need for the LLVM type. I forgot that. So we need the param. We have the params. Actually, we take a reference to that. So we need this, and then we just pass the params like that, which means we need to dereference that one, dereference that one, and dereference that one. We need to dereference that one, dereference that one, dereference, and here we want to dereference that one as well. So otherwise it will be bad. I think that would be correct. And now we can do add func type context signature params I type signature params I var ABI info, and then a list of params, right? And let's see, the params is that, and then let's see that it wanted types. Type. So now everyone is happy here. So because of this, now since we already did this one, and we don't need this stuff. And finally, so if signature failable and we actually have, and we have a signature ret ABI info, because we might not have one because it's void. In that case, we do this adding this if it's failable and it's not void, meaning ret ABI info will be null. Then we do this, and we have the type of the return type. So actually we have the pointer, right? Type get pointer to the signature R type, and then maybe lowering and stuff, but we don't need that. And then that's going to happen anyway. And then we have the ABI info, which is the return signature ret ABI. And then we take the params there. So everyone is happy, and it's going to give us the correct thing here. So we don't need this part. This is just done already. No need to do that. No need to do that. It's all in all, it's pretty much simplified. And now let's see what happens. Oops, we have params and we have parameters. So we have vex size. Oh, sorry. Maybe I was wrong. I was like too fast. No, it's going to be like that. So vex size params. Right. Let's see if this works. Boom. No, it probably. No, it didn't work. And oh, hang on. We're going to meet parameters as well, the attributes. So we are adding the attributes, and now we have to do similar things, like if the so this is different. So okay, so let's see, the return ABI if the signature is like a failable, then we just want that one, otherwise we want the return ABI info. And we're going to do like emit stuff for that one. And then we go through the parameters. And like if there is a signature, hang on, so fail, if we have like the return ABI info, we want to do that one. And emit parameters for that, which is then going to be like at let's see, at index is going to be like the 2. No, yes, going to use this one, I guess, signature ABI info. He's going to use the same thing here, so yes, going to take this one in there, and in there. And in this case, we want that. Like this. We just shorten that to info. So info and info. Okay, now there is something wrong with this. Oh, maybe it just wasn't happy about doing that. Okay, so params, and here is not going to do anything like that. Okay, this looks like it could work. It didn't, and let's see why. Oh, maybe it didn't assign the start and end of the param index start thing. So when you do that, you want to say what is the start, but we're doing that. Presumably it's, let's see where it breaks. So it breaks here. In the return ABI info, it has an index start and index end. It's going to take one more, and it's going to be a direct one. So this is going to be, hang on, did I forget a +1? No, the index end is going to be same. So let's see here. If it's not assigned for some reason, let's go back. I don't think I'll finish this now because in general I not do too much in a single suite. And so on. So we are going to go here, and we're going to add that param, and then we're going to, did we really add it? That is the question. So let's see if we get into this one here, right? And that's where something weird happens. Okay, we passed that one. So for some reason, oh no, hang on, this is the, no, signature, it's failable, and it has, signature has a ret ABI info. The function has looking here at this one. No, that was the wrong one. Info, signature itself, where is it? The signature is, oh, we're getting this error on something else. Okay, and in this case we why do we get this? How did it look like before? Okay, so if signature if it's a failable, so that was the case, right? Oh, yeah, that was not correct either. But now I think it's breaking at the right place. So in this case, it's printf. Okay, that doesn't make sense. Cogen. And we have an info, and it's a direct one, and it's a pointer. Oh, it doesn't have a start. It doesn't have a start. So we're going to go to the first parameter. We have the ret ABI. That one is done, and we don't have a failable, right? So we go in here. So we are at, let's see here. This is the. I think this is the printf one. We are doing the decal. Yeah, so we're going to printf one. So in this case, we shouldn't have a failable info, so we should pass that. We should have had the ret ABI one, which we already set here. So now we go to the next param, which is going to be this one, which is going to be the string one, right? So the parameter here is the message. And we're going to take our ABI info, and it's going to be what? It's going to be a direct one, I think. Yes. Now we go into that one, and it's going to look at the index, which is wrong here. So I don't know why the index is wrong. At this point, it's param index start. I think something is going wrong when I do the assigning these. Maybe they don't get assigned or something. So let's see here. So maybe the params aren't. Oh, damn it! Right, I was worried that I would do something like that, forget to do that. So okay, now we're done. Now we're done. And now we should do that because, well, there's a danger using these and referencing them incorrectly. Okay, let's see if it crashes now. It is there, and then we go to something, and we'll see what happens to this one. Ooh, it gets transformed into a void star and an I-64. I don't know if that's correct or anything, but we get this one here, which is correct. I am going to check what happens if I have a struct, and I'm going to return that one. So I have a struct. Let's see, this contains two void pointers in Clang. And it's going to return a struct B, and it's called foo, and it's a void thing. No, it's going to return an int reference. So what I see is that foo will do what? Okay, it won't. Okay, I need to make a function there. it will return to int pointers. So this is wrong. It should be classifying the second one as a void pointer as well. And the question is why it doesn't. So that's interesting. That seems like it's buggy here. Those changes I did might have broken something. Luckily, I can do this simply this way. I will just debug this. So we go into the failable. We do the type lowering. We check if it's a structure and if it's a rectals. And then we go and classify this one. Go inside and we discover that we do a type lowering on the type, and what happens to it then? So it's still an error union. We continue, we find it's an error union, and then we classify both high class and low class as integer. Which is consistent with having pointers. Now we break, and then we have decided that the low class is an integer, and then we get the type up there, and we get the plain type. And let's see what we get. What type? We get a pointer for the high class. So let's see what happens then. So we have the high class. We don't have that, and the high part is now decided that the high part is what? A type int bits. Why? It should have been a pointer. So I just need to discover why. Okay, one more time. It's still going to say like the same thing, but it's bad that it doesn't really, do the right thing here. So okay, we classify the return type, going to the type into lowering, going down and classifying it. Done. We go through here and we know that the low result type will be a type plain, which contains a pointer, and then the high part will also get a int bits. Damn it, that was one I was going to look at. Done. We walk past that one and go into get int at offset. So now we'll look at the source types, type size, and yeah, hang on, we don't do the offset, right? And I think this is weird. I don't think. Maybe we should do something at the offset. Get int type at offset, and I'm just going to say like, okay, if the offset isn't 0, but is that really what the LVM says about this? LVM says the following. Oh, if the offset is 0, then we can do some simplified handling. Basically saying if it's a pointer type. Okay, so this is incorrect. So if the offset is 0, then if it's a pointer, so if it's a pointer or an integer type, if type kind is type pointer, type pointer. So we have 2 of those. So if type is a pointer or type kind equals type long, u64 or type kind equals type I64. In that case, we just return that type. So that's like the super simple handling. And then we have something else. Let's see here. So if we have those, then we return the plain type, sorry. ABI, I have this wrapper that I made. It's because we don't have variable bit widths inside of C3. Okay, so that's the first thing that happens. Then if we have any of the smaller ints, f type is integer type and type built-in byte size is less than what? Is less than 8. Then we return a new int bits, which will be then we have another test. So f, here we have it, I think. Right, this one. Okay, so this was why I was using this one. Okay, let's use that one. But we have something important here. So this is just going to happen if in this special case, and this is sort of so if it's not one of those, now here we have the handling, normal handling, and these cases. So we should probably do like f type is integer type. And f type built-in byte size equals 8. Then we return this one, the plain one. F type built-in byte size is less than 8, and this holds. Then if, and this whole thing. In that case, then we just return again, I guess, the type. The same thing. So if a type is pointer, then also return this. Okay, so now we handle all these special cases for small ints. Now we go into the case where it's a struct. So f type as type kind equals type or type kind equals type struct. Then we go at it having these, trying to pull out these members. I guess. So then we want to do this. Otherwise, then we have like the array thing. So we also have like if it's if no, maybe I should keep the whole darn thing. So let's keep it the way it was. I did a boo-boo. Because it's mostly correct. It's this one that isn't. So if offset, if not offset, then we just return this one. Otherwise we just break, right? And in this case, if not offset, we just break, right? Otherwise we try that and then break. And then that means we are now handling everything correctly. We are going to reformat this one. So if it's not an offset, then we just return this plain type. If it's like the offset is smaller, then we will try to make it smaller. We're just going to handle that later on. If it's a member here, we're just going to take that as an offset, otherwise we break. If it's an error union, and here I think the source type needs to be like here. We need to assert that the source offset is 0, or the source offset is the offset is 0, or the offset is 8. And these are the two possibilities. And in this case, we always return the plain void pointer, or offset is greater than 8. So if the offset is greater than 16, I guess it's. So if offset is less than 16, then we return this one, right? Otherwise we break. And this, so if this is bigger, then we need plain one. So. Okay, so this should be correct for those. Then we just get the pointers all the time. And actually, this is incorrect. So if for the error union, I don't know, maybe we don't want the pointers. So maybe we want more like if it's less than 6, we left less than 8. No, if it's less than 16, then we want to return maybe, darn. Actually, we don't want pointers. So if it's less than that, we want to, if offset is less than 8, then return type useSize, right? And then if offset is less than 16, turn ABI type void pointer, right? And here we have useSize. So these are the way I am thinking of it. So let's see if I use this elsewhere when I classify stuff. Elsewhere we have it here as everything else, so it shouldn't affect anything else. I think we just like treat it as a pointer, and we don't get anything else there, except for the way we should treat it in LLVM. So we should get an LLVM struct type in context, and we do an, so we're not handling the array union correctly before we are getting a LLVM is weird. So array union should always be handled already. It's unreachable here. And if we expand that one, it looks like that, right? And if we expand a struct, no, if we expand an array type, we're going to expand this. No, this is, I guess we need to expand the parameter members. And this is a to do. And this is a to do as well. So let's see here. I need to define this one, I guess. LLVM int type in context, and it's a, oh yeah, it's a pointer sized, so get type context use size canonical. So this is how you create your structs in LLVM. And we want to get this one twice. Create a struct with those elements, and this is incorrect. Create struct type is an anonymous struct. That should be one. Okay, so this one should create a struct for the array union. And we had something there. And we have something there. All right. Now it looks like I64, which is correct. We changed that. Oh, I was a bit worried there for a while. All right, so that looks good. There are more things to be done, so I'm still not doing a check-in here. I'm still at master apparently. I should be doing a checkpoint checkpoint x64, x32, arc64, win64, and I do a commit, and maybe I will just, because people were wondering about this, so I'm just going to make the dev branch. I don't think there was one currently in the remote. Let's see here. So remote doesn't have one. And I'm going to push this one. And you can have a look. And there's a lot of stuff there. So there we go. Thank you for watching. I will look at now. I'll look if there are any questions. No, there wasn't. So I'll put this on YouTube. And take care.